All right, so today we're going to discuss and show you how to do the prep work for a 6G 2-inch unlimited open root certified weld test. This is going to be the prep for your pipe. This is a piece of 2-inch Schedule 80 seamless high pressure pipe, and I'm going to show the importance of why you need a bevel and how to grind it and get everything prepped so you can start doing your tacks and welds. I'm going to draw first. First, when you're doing your pipe weld, you need to have a bevel on anything, not just your pipe, any type of metal. So here is what a piece of metal looks like that has no prep done to it. Okay, it's just two pieces of metal and a gap in between, and then you take and you put a weld on the top, whether it's stick, MIG, or TIG, or whatever. And when it burns in, it melts the base material in just a little bit, and you get a weld that's on top of your metal. And that leaves all of this right here as open space. That's a weak point. So what we're going to do here is here's a side view cut of a pipe and bevel, what I'm talking about. Okay, imagine this is a fillet, a cut lengthwise down your pipe of why you need a bevel. Most weld procedures or weld standards call for some type of bevel on your fit up for the procedure of whatever it is you're doing it for, whether it's NNSYs or ASTMs or other welding standards. So with this spot right here, this little flat area, that's called your land. And most procedures call from a 0-inch to up to 3/32 of an inch of land area. I myself prefer 1/16 inch land. That's what I prefer for right here. The face of the land to the outside edge of your bevel, right here, on one side, for the procedures and standards that I have used in the past, is 22.5 degrees. Okay, your total radius or your total angle right here, this part to here, that total radius is 45 degrees on most of them. Not all procedures or standards are the same. This is just a basic, and this is what I have done for the most part in the past. Okay, 45 degrees. Each beveled piece is 22.5 degrees. And then you have your fit up. You have a gap, that's why it's called open root, of between 1/16 to 1/8 allowable gap between your pieces. Okay? When you do your welds, I was showing right up here on what it looks like when you don't have a bevel. When you do this, now my angles are exaggerated in the drawing, so don't yell at me for it later. When you do this and you go to do your weld, now you have a thinner area to join together your base material. So when you start your weld, your puddle is going to be down here, and it's going to melt your base material into your puddle, and then it's going to come through, and it's going to be a little, it should be a little convex weld on the inside of the pipe, basically making a smooth weld, a smooth seam on the inside. And the reason for that is because if you have a piece like this, say this is a piece of pipe, and you have your weld on the top here, and you only have this much penetration, especially in your pressure sensitive type piping systems, ammonia, steam, pressurized potable water systems, whatever, what happens is you have flow going one direction or the other, running along the inside of this pipe, and it hits this, and it creates a little vortex, which causes a turbulence, which will eventually eat and erode the pipe away, which can weaken this joint and either break it or create a pinhole, which will require this whole section needing to be replaced. Whereas with the other pipe, it hits and it just flows smooth past it. That's the reason for the welds being like this, and why there's testing and procedures and standards that have to be followed. And now I will show how to prep your pipe. All right. So, Schedule 80, 2-inch pipe, seamless, high pressure. We're going to get it prepped so that they look like this. This is what you need to have for a test. I'm going to show how I do it. I have a jig, a fixture I made here to keep everything so that it comes together nice and even. See, right there. So, I'm going to show how I do it. Okay. First, put on my safety glasses, and I use 4.5-inch hard knot wire wheel to start. Now, I do it that way with a hard knot wheel. If you notice, I always have the direction of the wheel going away from me, so that way if it grabs, it'll throw it that way. Well, I use a hard knot wheel to take the mill scale and the rust off without taking any of the base material away from the pipe. I want everything that I can get there per specs. Okay? So now that I've got that cleaned off, now what I'm going to do is I'm going to use a 4.5-inch grinder with a 60 grit flapper wheel, because that's what I prefer, to put my bevel on here. Now it's going to be approximately as close to 22.5 as I can get by hand. Out in the field, you're allowed a little bit, because of you don't have perfect conditions, but this is how I do it. And I also use a grinding wheel in the field as necessary, but I'm not in the field. Now that I have my bevel cut, I'm going to take first this half round bastard file. I have a little bit of a burr on the inside of my pipe. I'm going to file that out. On both pieces. So it's nice and smooth. Then I'm going to take my die grinder with a worn out 2-inch flapper wheel. I'm going to clean the inside of this up because since I'm prepping for a 6G weld test, I want everything as clean as it should be, as it can be, to have that much better of a chance of passing the certification weld without any issues, without any porosity, without any ink inclusions or anything. And a bad base metal can help do that as well. Nice, clean, no rust, not quite polished, but almost. Same thing. Now, I have one pipe coupon. Both ends are beveled. I had this prepped for earlier as a backup to show, and these are ready to go. When I'm ready to do my weld, I'll put it in the fixture with my clamp in the way, so that way I can get it set up and show you that the next on how to do the tack, your fit up, your tack, your root pass, intermediates, and your finals.